lesson 4.3 is about using models to represent reactions. So we have balanced chemical equations that tell us the various forms that can be translated into symbolic particulate representations. This little section is just to help you realize when you're looking at models and you're drawing models that you need to be accurate in how you represent a chemical reaction. Or if you look at a model, is it the correct model to represent what you're supposed to be finding? So for example, just right here, we have methane gas, which is CH4, breaking into or reacting with O2 in a combustion reaction to create CO2 and H2O. Now the top is not balanced because if we saw this, that we see that there's not enough hydrogen, so then you would put a 2 in front of the water, and then in order to balance the oxygens, you would have to put a 2 in front of the O2. Remember, making sure equations are balanced are important. Well, when looking at the particulate model here, we have one CH4. Remember, the black or gray represent carbon, the white or the lighter colors represent hydrogens, and reds represent oxygen, usually in pictures. So we have two O2 molecules because what happens is you can, based on valence electrons, connect 4 total things to carbon. So when we lose the H's off, then we have 2 oxygens that can form double bonds to make the carbon dioxide, and then we have the other 2 hydrogens will go to the other O2 molecule to make the 2 waters. So we've used kits, modeling kits, to see the molecular shapes of things. We have looked at graphs, graphical data based on experimentation. We've looked at different pictures. You've had questions where you're supposed to identify based on pictures. So this is just a way for us to help us see something that you can't see by the naked eye. Okay, this I got off of page 157 in your textbook, and it shows the reaction between potassium chloride, which is what the KCl mean, and silver nitrate to form silver chloride and potassium nitrate. Now, we've had trouble with this on our last unit. I remember looking at one of the free response questions. I don't remember if it was a progress check or if it was a test question or what, but when you are drawing your ions from a thing dissolved in water, then you need to make sure that they're in the correct ratio. So KCl is a 1-to-1 ratio because they have a +1 -1. So you should have the equal amounts there. Same thing with the silver nitrate. Okay, now would I make you really draw nitrate like this? Probably not. You could probably just draw it as a circle, but label it as NO3 -1. But if you had like a +2 with a -1, like calcium chloride, which this is not involved. I apologize for the writing because I'm not writing on the board right now. But you have to have double the amount of chlorides as you do calcium. And some people had problems with that on our one of the last problems that we did. You didn't receive credit because you didn't have twice as many chlorides as you did calciums. So be careful with that when you're drawing your representation or when you're trying to identify a representation. But what happens when the 2 solutions are mixed together, all of the ions intermingle until the chlorides will make a connection with the silvers, and then that's where we get our solid formed of the silver chloride, and the potassium nitrate is still marked as aqueous, so that would be broken up and not included in a net ionic equation, and that's because they're still floating around in the resulting solution in the water. But the silver chloride clumps together because that is insoluble. Okay, so to help us more recognize our models and how they're correctly used, we're going to do an in-class activity now in class today to help us with this. And if you have more questions, please let me know.